Hi, welcome to the Ben and Chris show. I'm Chris Headland, Associate Professor in the School of Computer Science at the University of Lincoln. This is Ben.
Hi guys, I'm Ben. I'm a PhD student at the School of Computer Science at University of Lincoln.
Today we're getting loopy.
Yeah, so today we're going to talk about two main things, really. We're going to talk about conditions, and then we're going to talk about using loops, so how we can use things like iteration to do some really cool things. And we kind of touched on this last week with well, I think it was last week, wasn't it, Chris, where we kind of had a bunch of statements and we thought, oh, there must be a better way of doing this. That's why we're going to introduce loops. So what we're going to talk about first before that is we're going to talk about if statements, selection, and this kind of stuff, and we'll talk about that. So yeah, I guess I'll start with this then. So before we actually start and get into the meat of things, what I want to do is firstly quickly point out what a comment is in Python. So I was meaning to talk about this last time, but it didn't really come up in conversation. So there are things in Python called comments. So say if we write a line of code like this, right? We just have hello, and we just click run. You see it says hello over here. Now, there are things in Python called comments, and in fact, for that matter, they're in most programming languages. From Python to C to even lesser known ones. Comments are everywhere, and they're really useful tools. So essentially, what a comment is in Python, you put a hash symbol like this, and you type something like this print hello, or you can put anything here, right? You can type this, whatever. But the idea is that this comment here, this line, is going to be ignored by the computer. So as you can see, it's flagged up in gray here in the editor. This just means it's going to be ignored by the computer, basically. And you might think, well, what's the point in that? What's the point in these comments? It doesn't seem to make much use, but they're very useful. They're very useful for writing good code, because if I write some code that to me is quite obvious, and I give it to someone like someone like Chris who hasn't seen that code before. Yeah. Sorry. I mean, if I give if I give it to Chris has never seen this code before, so he might not be exactly sure what it does. But by writing comments, I can kind of say, hey, look, this code does this and this code does this. And the reason I want to introduce comments is just because we're going to be using comments throughout today. So if you see a line and it's gray and it's got this hash before it, it just means it's a comment. It's going to be ignored by the computer. So if I run this, as you can see, nothing, it runs exactly the same thing. If I take that hash out, suddenly we start to get errors because it's trying to run this line. But if we put a hash before it, then Python knows that this thing here is just a comment. We can put text in there. So comments really are just for annotating your code. If you give your code to somebody, or if you come back to your code after a really long time, you can kind of figure out what the code does, and it's really useful. And throughout today we're going to be using it for annotating parts of our code. I'll say, hey, look, this line does this, and I might write a comment. So if you see this, don't be surprised. It's just a comment. That's all. So yeah, what we talked about last time and the week before, one thing we touched on was arithmetic operators. That's the kind of fancy name for things like 5 plus 5, right? So 5 plus 5, this thing here, you might have heard me talk about this plus symbol as an operator. And you can kind of, the way I like to think of the word operator is it kind of operates on these two things. 5. The technical term for these is operands, but we don't have to worry about this. Just think of things like plus, minus, divide, times, even things like powers and stuff like that. These are all operators, but they're a specific type of operator. They're called arithmetic operators. And all arithmetic operators are really is they're to do with arithmetic, right? So 5 plus 5 is arithmetic. It adds this operator here, plus adds two things together. Subtract, it subtracts 5 from 5, so it gives us 0. So these are arithmetic operators. And the reason I'm talking about this is because we don't just have arithmetic operators in Python. We also have other types of operators. So there's other ones like relational operators and logical operators, which we're going to talk about today. But we have to talk about these before we actually get into selection and stuff. And I'll introduce that. But yeah, the idea here is we have these operators like plus and minus and times and all this kind of stuff. And these are called, well, if I see to use the comments, these are called arithmetic operators, right? So it's things like this, and this, and this. They're arithmetic. They involve arithmetic, where there are other ones, and these, you've probably seen things like this before, where you do things like 5 more than 4, right? Now this thing is another thing in Python, and this is another operator, right? Because again, it has 2 things here. This is a relational operator. So what this does is it's testing some kind of relationship here, and we obviously know this as the more than sign. So this is going to test, rather than 5 plus 4, where we'd add the result and get 9. What the more than symbol does is, because it's a relational operator, what it will do is it will test if 5 is more than 4. And we have the less than symbol, we have the more than symbol. There's a bunch of others which I'll talk about soon.
So the relational operators are kind of like it's asking the software a piece of question. It's asking it a question, right?
Yeah. That's exactly right. I said, things like where you have plus and minus and stuff. You're not asking a question. You're kind of telling the computer, "Hey, do this, right? I want you to take 5, and I want you to add it to 4, and I want you to give me the result." So you're kind of, you're telling the computer, "I want this sum, right? Do this sum for me." But as Chris says, this is asking a question. Really, you're saying to the computer, "Hey, is 5 actually more than 4?" And if let's just run this, right? So 5 more than 4. So let's run this. Now we get this true out, right? And that's quite interesting. But what if we do the opposite and we say 5 less than 4? Well, now we get a false, right? And we haven't really come into these. We haven't bumped into these types of data before. We've seen things like integers, so whole numbers like this. We've seen floating point numbers like things like this, and we've also seen strings, bits of text like hello, whatever, and so forth, right? So we've seen 3 types of data so far. But one thing we haven't seen is these things called Booleans. And Booleans are very easy, and there's a funny story behind why it's called Boolean. A guy called George Boole, who I believe, I don't know if you can correct me.
Named it after himself.
Yeah.
That's less of a funny story and more.
Yeah. But he grew up in Lincolnshire, of all places. So that's great. But this guy George Boole, Boole with an E, like this. He was one of the kind of founding fathers of binary logic, things like true and false, and this type of logic made its way into computers and also programming. So a Boolean type, right, is just something that can hold the value true or false. Very similar to a 0 or a 1. You can think of this as a 0. You could think of this as a 1. So a Boolean, right, and I'll spell that out for you. A Boolean is just something that can hold true or false. It's like a light switch. It's on or off, or it's like a light bulb. Again, on or off. So that's what Booleans are. So what this is doing, when we do something like 5 more than 4, we're asking, is 5 more than 4? And what the computer says is true, right? It says yes. You can.
It's important to remember that there's only 2 possible answers to that question.
Yeah,
there is. If you have to, something is bigger, it's either is or it isn't. There's no sort of.
Yeah, there's no in between. It's either yes or no, true or false. So that's what a Boolean is. When we ask the computer this question, 5 more than 4, we get out an answer here. In this case, true. But if we do it like less than, we get out false. So essentially, the computer is answering our question for us. If we say 5 more than 4, you can kind of see this as 5 more than 4 question marks. Then what this does is the computer kind of runs this, and either in this case returns true, or if it's something else like 5 more than 10, it'll say false because 5 isn't more than 10, right? And that's what a Boolean is, right? A Boolean is just a true or false value. So we've looked at integers, 1, 2, 3, and 4, all the set of whole numbers. We've looked at real values, or as they're called in programming languages, floats, because they have a floating point. And we've looked at strings, which are just strings of characters, which are text. But we're now looking at this thing called a Boolean, true or false. And you might be thinking, that's brilliant, but what's this got to do with what we're going to talk about? Well, it turns out that these are really useful for a bunch of different stuff we do in Python and other programming languages. So these, because they're asking a question, they're relational operators, right? So there's less than, so we can ask, is 5 less than 10? In this case, it will say true, because 5 is less than 10. There's more than, we can say 5 more than 10. There is more than or equals to, which is this thing, right? And I don't want to get really stuck on the details of all this because it's a quick Google search, but the most important part is that these are relational operators, and we're kind of asking that question. But there is also less than or equal to, and there's an interesting one which is 2 equal signs, right? And this always catches people out. I don't know how many times people have come to me with problems in their code, and they've said, "Oh my God, Ben, my code isn't working," and it's because they've used this in place of a single equals, or a single equals in place of a 2 equals. So what this means, and I'll explain it in a second. What this means is equal to. So this is saying, is 5 equal to 10? In this case, 5 is not equal to 10, right? So if we run that, we'll get false. But if we say 5 equals 5, we're asking the question here, is 5 equal to 5? That's what this is saying. If we run that, then we get true because 5 is equal to 5. So this double equals, these two, is asking the question, is 5 equals to 5? Now, if we put an equals, suddenly we're going to get loads of issues. It says expression cannot contain assignment, blah, blah, blah. And the reason is that 1 equals in Python, well, we've already seen this. It means assign a value. So if we have a variable called hello, and we set it to the value 5, this 1 equals means assign this variable called hello with the value 5. Whereas this 2 equals just means this. It means is it equal to 5? And we could replace it with hello here. We talked about variables last week. And what's going to happen here is it's going to replace this with 5 because this variable hello is 5. So we're asking, is 5 equal to 5? But the reason I'm stressing this, and you might get the point already, but the reason I talk about this is because it's a very common mistake. People will have some condition that they're trying to test. They'll try do this. They'll try ask, is this thing equal to 5?
I mean, it's because a double equals isn't part of our normal lexicon, is it? We're used to, we all learn in math that when we have an equal sign, what is on the left of the equal sign is equal to what's on the right of the equal sign. So it's not a big jump there to understand that we use an equal sign to assign a value to a variable. We're saying this variable is equal to this thing, whether that's a string, a floater, an integer, whatever. But double equals, we don't really use those anywhere. But like I say, we in this case, we're using it as a test.
Yeah, and Chris is exactly right. This thing is quite alien to people, and I think that's the reason people struggle quite a lot with it. Is it's in math we're used to looking at this 1 equals and thinking, oh right, okay, we understand what that means. But then we have 2 equals, and suddenly it gets a lot more confusing. So just be aware of that. And like I said, the reason I bring it up is just because there is a big difference between this 1 equals and 2 equals. One equals is assigning, so we're saying this variable called hello is equal to 5, whereas these two equals we're saying is hello. I should update this. Is the variable hello equal to 5? That's what this is saying, right? And if we run this again, we just get true, which is great. There is also another one, which is exclamation mark equals, which gets a bit even more confusing. So this means not equals to. And there are some cases where you do use this. This just means not equals to. So if we run this, we know hello is 5, right? Because we're setting hello here. This is going to be 5, and we're saying, is 5 not equal to 5? Well, no, because 5 is equal to 5. So we're going to get false. So these two things, this and this, are kind of the opposite, basically. And yeah, that's relational operators. And again, I've talked quite a lot here about just we're asking this, the computer a question, and you might think, well, how is that useful? But this kind of logic underpins most software. Things like if you've clicked a button, there's going to be some condition in there somewhere, like if mouse button press down or something. That these kind of conditions do underpin most software. So just they're quite important. So I'll give you a I'll try think of a good example of where we can use these. I suppose one way of doing it is say we have a grade. Say we get, I don't know, 80% on an exam. So the student's grade, right? So say we have a mark out of 100, and their grade is 80. And what we could do is we could print out something like has the student or has the student passed or something. Has the student passed? And then we could print out a condition. So we could say grade is more than, and I don't know, let's say the pass mark is 30%, right? So what we could do is we could, this is a very short program, but now we're just saying, just print out some stuff here. So what this is saying is we've got a variable here called grade, which, obviously you'd replace the value here with whatever grade they've got. And then there's just a line here. It's going to print out, has the student passed? And then what it's going to do is it's going to take whatever this variable is, grade. In this case, it's 80, and it's going to do that test, 80 more than 30.
I just want to find the course that has a pass mark of 30%.
Yeah. But yes, say for example, we've got this grade. We've put in 80% here, but say they get something like 15. So we've run this with 80. It says, has the student passed? True. So true is yes, they have passed, right?
Because there's a really interesting question in the chat, actually, Ben.
Yeah.
Throw it up on the screen. Steve says, is the convention the same in other languages such as C++, or does it differ depending on the language?
That is a good question, and it does. In some cases, it does differ. If you mean relational operators, then yeah, it does differ in some languages. Although in most languages, for example, less than and more than, are kind of the same usually. But you can have things like I can't remember what language it is, but not equals this thing, which I just showed you. Sometimes in some languages, it's this. It means this. We also have things like
there's languages that use both as well, right?
Yeah. So there's a bunch of other ones. There are even ones where you've got things like we actually write in LEQ and greater than equal to and equal to. There are other types of operators as well. So things in things like PHP and JavaScript and that kind of stuff. You've got a triple equals, which is kind of like the double equals, but I don't really want to get into why there's a third one there. But basically, it's this is it equal to, and this is it exactly equal to that value. And I won't get into what that means because it would just be confusing. But yeah, to
be honest, I don't think I've ever found a situation where, I mean, I know people do it, but I've
Yeah.
never actually seen sometime that someone's used triple equals in anger. Right?
Yeah.
I mean, I know it exists, and I've written it because it's been the right practice to do.
Yeah.
But also the double equals have worked, So, I think the basic answer to this is, I think in most cases the standard mathematical operators will work. C++, certainly C#. It's very, very similar to Python. Java is mostly pretty similar. I mean, I can think of a couple of things that are a little bit different. But generally speaking, they're all fairly similar. With usually a few little eccentricities. But generally, if you try to write the code in that language, if it throws an error, it will generally tell you why the error is there. And actually, some of the compilers now are smart enough that they'll say, "Oh, you've used this operator. You meant to use this one." It still won't run until you've changed it. It's not that smart, but it will usually tell you what you've done wrong.
Yeah, and that's the thing. There are. I think the more esoteric your language is, the more you start to see these things creep in. Like in some languages, this means the single equals, and this means the normal, like the double equals. So it can get confusing, but as Chris says, a lot of compilers now are smart enough to kind of point you in the right direction. But for the most part, yeah, they are kind of the same, really. They are very similar.
There's not a lot of popular languages that go off track with that, is there?
No, I can't think of any off the top of my head, really. But yeah, it's a really good question, actually, and it's interesting because there are so many differences between different languages. But the cool thing about learning how to code is if you learn something like Python, it's very easy to kind of transfer into something like C or something else, because the syntax is very similar. You've got things like the equal sign, which roughly means the same thing. These operators, the relational operators, are kind of the same, but a lot of the hardest part about programming is not actually learning what these things do. It's more breaking down the problem into code itself, which is kind of, I don't know what the word is for it, Chris. Can you think? Is it like
computational thinking, I suppose?
Yeah, computational thinking. So it's this is why I tell people, like, it doesn't really matter what language you start in. Really, you can kind of go from there. But yeah,
this is something I always say this at kind of when I'm chatting to first year students. Don't get too worried about the language. If you learn good programmatic practice, the language itself is just some syntactical rules that you can get that in a book. You can quickly figure out. Most of the challenge comes to actually write. How do I describe? Programming languages is this kind of, it's more of a conceptual framework, really. It's a way of describing a job you want the computer to do. And it's that, I think that's the hardest part, is thinking, how do I get this problem in my head into a way that the computer can understand it and solve it for me? If you can do that, actually the language is generally not the hardest part.
Yeah, I just to give you like a quote. When I was starting university, Chris will remember Steve, right? I had a lecturer called Steve, and he had a very good way of putting this. He said to try learn the language by learning all like the what these operators do and the brackets and all these, and learning what each kind of word means. It's like learning how to speak English by reading a dictionary. You'd know what all the words mean, but you wouldn't know how to put the words together to form a sentence. And I think it's a good point. And as we've talked about, programming is the hardest part of it, is kind of just getting that problem that's in your head. Say it's like build some software to read from a file or something like that. Taking that problem and kind of converting it into something the computer can understand is probably the toughest bit. So if you can figure that out, largely you can kind of interchangeably go from one language to another. But yeah, it's a really good question, actually. A very good question.
So Nadia, I assume that was agreeing with my comment. That's the hardest part of actually describing it in a way that the computer will understand. So yeah, I will completely agree.
Yeah. But anyway, I'll get back on track here. So there's so we've talked about relational operators, right? And relational operators, what they're kind of doing is the reason they're called relational operators is because they're kind of testing a relationship between two things. You know, we're saying, is 5 more than 30? It's asking, the question it's asking is about the relationship between these two things. Now there is another one. So we've looked at arithmetic operators, which is things like plus, minus, times, divide, all this kind of stuff. We've looked at relational operators, relational operators. So, you know, we've looked at more than, less than, and so forth.
I hate typing live because I always have so many spelling mistakes.
And then there's these ones, which are called logical operators, or sometimes they're referred to as like Boolean operators, because they do a true and false. And what these are they're just things like in Python, it's and, or, and not, and there are, I'm not sure if there are any others, but they're the main three. So what these logical operators are, is they kind of, we have two relational, say we have something like this. If we wanted to test if this is true and something else is true, so if we wanted to check if, you know, 5 is more than 20, for example, what this and does, this is called a logical operator. And this is something which is, you know, to go back to the question that we had earlier, this is something which is kind of unique to Python, I guess. There's not much languages which use the word and here. Usually they use two ampersands like this.
Yeah.
But
that's one thing, actually. To go back to Steve's question, the logical operators are one that you see massive variation between language. So sometimes it's symbols, sometimes it's words. Let's say Python is fairly unique that it uses words and symbols within its operation set. Usually it's either all symbols or you'll see all words. You know, like Ben showed you the example of the greater than GRN standard. But no, Python is a little bit unique. That uses these logical operators are words, but the relational and arithmetic are symbols.
Yeah, it can get confusing. It even throws me sometimes. I automatically go to type this, and I always get an error, and I'm like, oh god, why is that? And it's because I haven't put the word and. So in Python, I suppose as a new program, it's a lot easier to understand this, really, because this is all logical operators are. It is just testing if this thing and this thing is true, and if it is, it will say true. So let's
one of the best examples of this, I think it was in one of my first programming classes. The example was, right, let's create an 18 to 30s holiday booking system. Right, so you're only allowed to go on this holiday if you're between 18 and 30. Oh, it's just made me feel so sad. I feel so old at that moment. Right, so 1830s party, you could actually then break those down. So if you had a variable called age,
I'll type this out. Yeah, should I put something?
20, yeah. And then if we went in the first set of brackets, age less than 30.
Yep.
And then the set of brackets, age greater than 18.
Yeah. Okay. Yeah. So if we run this, in this case we get true. Yeah. So what this is doing, is it's doing two tests, right? It's saying, is the age less than 30, and is the age more than 18? So if we removed, if we removed this part, right? Well, suddenly anybody like of the age 7 or 6 in this case, sorry, if you run this,
gosh, can you imagine a 6-year-old going on an 18-30s party? that is literally that is a lawsuit waiting to happen.
Yeah. So
6-year-olds on a booze cruise. Wow.
But yeah, so
that's why you need your logical operators. That kind of menace.
Yeah. Yeah. Oh god. But yeah, that's what these logical operators are good for, right? Is that, if we were to ask the question, can they go on the booze cruise, right? And if we if we had the according to this program, right? If we run this, then yes, a 6-year-old can go on a booze cruise, right? So 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 that's one half of the problem. If we have something like age more than 18, well, suddenly if we have a 97-year-old here, then sure, yeah, now the 97-year-old can go on the booze cruise. But if we put in age 6, right, it will say that someone who's 6 years old can't go on the booze cruise. So how do we test for that range? Well, we can say, are they more than 18 and less than 30? So we're testing if they're between that range of 18 and 30. And the way we do that is the code we had before, right? So if their age is more than 18, right, and their age is less than 30, then this will return to true. So we'll try it with 6. Well, cool, 6-year-olds can't go to this booze cruise. If we have a 98-year-old want to go, then they can't either. But say we have somebody who's, I don't know, 21, and sure, it says true, they can go on it. So this is the power of these logical operators, and there are other ones. So there's and, which behaves exactly like, well, and there's or, which tests if either one of these is true. And I'm not sure of a good example to show that. But this just tests if this one.
A good one for or is doing. You can work out if something is above or below a range. So you could change that to or flip the symbols, and then you can work out if somebody is outside. So now you can say, are they not allowed to go on the party?
Yeah. Can they not go on the booze cruise? So yeah, for example, if we run this, if 21, it'll say, can they not go on the booze cruise? False, because they're 21. But if we put a 6-year-old in here and we run this, it's going to say true, because 6-year-olds can't go on this go on the booze cruise, obviously. So
literally hurt now.
it was a very
there is times that working if something's outside of range is really, really useful, especially again when we start looking at kind of data science reasons. Sometimes you actually just want to test if something is outside of a range. So if you're looking for excluding kind of extreme variable, extremes in a sec, you can set that up, and actually there's a whole other kind of test that you can do to work out what that is. But or can be quite useful there. You can also work out, if you're running, say, through a database and you're looking for if somebody has, if one of the item has a certain quality, you can use or in that. And not is kind of the opposite of and, really, isn't it?
Yeah. So not just kind of tests. It just tests like so. Say for example, we've got age less than 18, right? So what this condition will do. So say this will say something like, are they less than 18? So in this case, all we're doing is we're testing age is less than 18, right? That's all we're testing. So if they're 6, then it's going to say 18. If they're 16, it's going to say true, yes they are. But if they're 35, then it's going to say false, right? What not does is it flips this. So if we say not age less than 18, it's going to take true and convert it to false for us. So say now if we rerun this, it's going to say true. And I should really update this. It should say, are they not less than 18? In this case, 35, it is not less than 18. So not in this case is almost the opposite of this, which would be this. So all not does really is it just kind of flips false to true and true to false. So if, as a kind of quick example here, if I just did not true, then it's going to tell false. If we say not false, then it's going to be true. If we do, not false, it's going to flip back, and that's the idea here, is that it just changes true to false and false to true, and it can be very useful if you have something like if you have some kind of question that you're asking the computer, like, is something and something or something or something else. You've got this huge line here, and you just want to test if all of this is not true. Well, you can just say is not all of this, and then suddenly it'll work. But the main two really are and an or, and they kind of work the way you'd expect them to, and it can be very useful. As Chris mentioned, when you want to test against things like outliers and extrema and stuff, or can be very useful for that kind of stuff. So the next thing I want to talk about, and the reason I've kind of, I've introduced relational operators and we've talked about logical operators, and again, you might think, sure, that's great for these little programs, and that's brilliant. We can test these little conditions and stuff, but can we actually do something useful with them? And the next thing I want to talk about is a really, really important part of Python programming. It's this thing called selection, right? And the idea behind selection is that based on one condition, you can select to run one bit of code or run another bit of code. So I think in the first talk we did, I introduced this kind of recipe analogy where I said computers kind of look at stuff like a recipe. They go to the first step and they say, oh, okay, I'll do that. And then they go on to the second step and they go, oh, brilliant, I'll do step 2 now. And then they finish step 2 and they go on to step 3. And, what I mean here is they will do A, then they'll do B, and then they'll do C as well. So they'll come to this one, they'll run it, and then they'll come to this one and do that, and then they'll run this one. This is called sequencing, right? It's called sequence because it's going in sequence. It's visiting here, then it's visiting here, and then it's visiting here. And so that's what sequence is. Now, what selection is it's almost like I'm not sure of I'm trying to think of another example. I can't think of much examples today, but maybe one of them, for example, is in a recipe. You've usually got a part of a recipe which says, if your oven is a fan oven, then set the temperature to 180 degrees. But if your oven is not a fan oven, then maybe set it to 200. And the idea is that based on that condition of your oven being a fan oven or not, you set the temperature differently. And that's
there's also, you can even take it a step back, right? As we go through that process, if we look in the book and say, I want to make a flan, right?
Yeah.
And I look through and I look at the ingredients and think, right, okay, I need eggs. Then immediately I go, do I have eggs? And that is, I then kind of construct this kind of question in my head. If I have eggs, proceed with recipe. If I don't have eggs, get eggs. Right? So there's, at some point I've or find another recipe and give up, but there is a decision that goes in there, with that selection process. It changes what I do.
Yeah, and the key word here, is selection, because if that condition of whether or not you have eggs. So if you do have eggs, then you don't have to go to the shop, right? Or if you were to make a cup of tea, if the kettle's already boiled, you don't need to reboil it or something. But if you were to go out to the shop to get eggs, right? If you had eggs, then then stay in the kitchen and carry on with the recipe. Otherwise, you go off and get the eggs from the shop. And the idea there is that you're selecting what to do, selecting what path of decisions you're going to do based on that condition.
I'll tell you what, let's just write that out as a piece of code. So if we get rid of this and we create a variable eggs.
Eggs, yeah.
And let's say we have 2 eggs.
2 eggs. Yep.
Right now, we'll have what we call an if statement. So if eggs is greater than 0,
Yep.
so if we have more than one egg, we're going to print make flan.
Okay. I'll do that.
Otherwise, we'll have a get eggs. So we've got a basic little program now that we're now doing this selection statement in there. So if we have eggs, so we have this variable that holds a counter of how many eggs we have available. And we're going to go through this decision of if we have more than 0 eggs, so we have some eggs, we're going to make the flan, else we're going to go get eggs. So what does that do?
So let's run this. So we have 2 eggs. Let's run this, and it says make flan, right? So what this is doing is this is called an if statement. What it's exactly like you'd expect. It's a kind of question. You're saying if eggs is more than 0, and then you can kind of read this colon, and this colon needs to be here, by the way. If you take it out, it will say, oh, invalid syntax, well, all this kind of stuff. You have to put that colon there, but I like to think of this colon as the word then. You can kind of think of if eggs is more than 0, then do this thing, right? And I'll just put that back so we don't get any errors. So this is saying if eggs is more than 0, then print this, run this bit of code, and this else is just means otherwise. So you can kind of think of as otherwise, or if that's not the case, if this thing is not the case, then run this instead, right?
So if the number of eggs we actually had was 0,
yep,
it would now tell us the eggs. Now, so you can think of, and this is for me where it gets quite powerful. So if you replace in the if eggs is greater than 0, if you replace the 0 with eggs required, and we have another variable called eggs required
equals
2. So now, and again, this time, what we're doing is we've got 2 different variables, so we can adapt this for all kind of recipes. So let's say I'm going to make omelets today. So change make flan to cook your eggs. Sounds like an insult. Go cook your eggs.
Go cook your eggs.
Yeah. So we can take this to a really basic kind of recipe or stockroom kind of testing system. So we can change the eggs required. So I'm going to make an omelette. So I now need 4 eggs.
Mm-hmm.
And let's say I've got 6 eggs. And again, this will work in exactly the same way. Because 6 eggs is more than 4 eggs, I can cook my eggs.
Yeah. So if we changed eggs here to 3, right, then it says get eggs, because this thing is going to be 3 and this thing is going to be 4, and 3 is not more than 4, so it's going to say get eggs because
Wisdom
they need
by Ben.
Yeah.
3 is not more than 4.
Yeah. But this stuff is really, really powerful. As Chris says, this, it kind of, this is the backbone of most software is this kind of testing for conditions and saying, if this, then do that. For example, a really basic example, right, is let's just comment all of this out, right, and let's just do something like you've got something like passwords, right? Password equals eggs 1 2 3, right? and basically you can do another if statement. You can say if password is equal to I don't know, the actual password, which would be hello there 1 2 3 4 something, right? Then you can say something like access.
Tell you what, do that as a text entry, Ben.
As a what? Sorry.
Text entry, because we haven't done. Text.
Yes. Okay, I'll talk about that. All right. So there's one thing. This input thing, what this does is it will allow you to type it in over here. So I'll just show you a basic example of this. So say we put enter your password here or something, right? And then we run this. Suddenly, look, we can type stuff over here. So I can type, eggs, 1, 2, 3, and it doesn't say anything, right? If I put an else here, I'm saying if the password is hello there. Well, okay, I'll change this to eggs 1, 2, 3, so we can kind of get. So this is saying if the password that they've entered is eggs 1, 2, 3, then say access granted. Otherwise, do something different and say access denied. So here it says enter your password. If I type in hello, it's going to say access denied. But if I rerun this and I type eggs 1, 2, 3, it says access granted, right? And all we're doing is this thing here is just asking the user to type it in for them. This input.
Let's go back to the recipe. So if we delete this, Ben.
Yep.
I think we're going to end up missing out on loops there. I think we're going to end up going to loops next week. But if we uncomment all this, if eggs required is an input,
yes,
of how many eggs does this recipe need?
How many eggs does this recipe need?
And if eggs is an input of how many eggs do you have?
Do you have? Yes. So one thing worth noting here is if we run this, right? If we run this and we type in, 5 and 1, it might give us something a bit strange, but basically this input thing will always give us a string. It'll always give us text back, and the way of converting that, we already saw this kind of stuff. We saw, do you remember str, right? So this str of 5, what this did is it took 5 and it changed it into 5 like this. Now there's another one called int, right? And what this does is it takes something like 5, like this thing here, and it will convert it into the number 5 for us. And what this input stuff does is it will return text, right? So we need to convert that into a number for it. So we have to put all of this in int, basically. But now, if we run this, we can say, how many eggs does this recipe need? I don't know, say 4, right? And how many eggs do we have? I don't know. 3. It'll say get eggs, right?
And actually, what we could do, if we go to that print, we can get it to tell us exactly how many eggs we need to get.
Yeah. So get. So again, using string
back.
Yeah. Now we have a string concatenation. So do you remember we did get and we'd put something like eggs, and this would make get eggs like this. So what we're going to do is we're going to say get so many eggs, right? So let's just put in so these eggs and eggs required are here. So what we're going to do is I'm just going to type this out, get and in this case I believe it would just be eggs required minus eggs.
Yes.
So let's just try this. So say again
4 and 3 again. 4.
You need to get 1 because we got 3 eggs and we need to get 1 for 4. Because what we're doing is we're saying you need 4 eggs minus the amount of eggs you've got, which is 3, and it's going to say you need 1 egg.
So the reason I thought this was quite a useful example, and it kind of, like I say, I think we'll end the call. Sorry, end the show. There we are. So used to being on Teams. The reason I thought this was kind of useful and why we've not gone to loops, and like I said, we'll do a whole episode on loops next week, is now we have an interactive program. We've got a piece of software, very simple, very rudimentary piece of software. But hopefully you can see now we can ask the user for a bunch of inputs. The computer will do some checks in the background. Not only checks, it'll do a little bit of math, and it will give the user some useful information. Now, in the grand scheme of things, if your recipe requires 4 eggs and you only have 3 eggs, most people will be able to work out what they need to do without software assistance. But hopefully you can see that you can expand this into something quite helpful. So right, okay, Steve might have just corrected our math. I'm just going to bring up this one. Would that be eggs greater than equal to eggs required? Otherwise, you'll be asked to get 0 eggs when eggs equal eggs required.
Yeah, I think so. So let's just try this, right? So say if
I always tend to drop an egg, so it's good to have a spare.
so if we put in something like 4 and 4, is this right? Something like that, and then it should say get 0 eggs. Yeah. So if we change this to something like that, so say here now we've got 4 eggs and we put in 4, it's going to say cook your eggs, and the reason is because we were off by 1. This has an acronym, OOBB, off by 1 error. Usually being 1 out is is a kind of common error. So yeah, we kind of corrected it using that.
And there's another question actually also from Steve.
Yeah.
True or false is not always a logical answer to a question. Presumably you can make an output string of your choice if a condition is met as well. Is that where the if statement comes in?
Yeah, basically, yeah. So based on that condition, so this thing here, so I'll comment this out. Let's do something like, let's make a variable called a. Let's set it to 5, and if we do something like print a is more than 3, then you're right. Essentially, what it's going to give us is going to give us true. But if we wanted to, instead of this, say yes or no, that's when the if comes in, where we say we take this condition here, a is more than 3, and we're saying if this thing is true, then print yes. Otherwise, print no.
I think it's fair to say as programmers, we have a slightly different take on the English language as a whole, right? Because I mean, most of the time I won't even use true or false. I'll just have a 1 and a 0 kind of pop up because when you're writing test code, you quite often do that. But you're absolutely right. To make your output a lot more readable, you'll often need to convert what the code thinks is logical into something that the user will think is logical.
Yeah, and there's a couple of ways of doing this. I mean, if is one of them. There is another one called a ternary operator, which looks, you could do this thing here shorter, and it's called a ternary operator, but I won't get into that because it's there's no point really, and I'm sure you can look it up. Yeah,
we'll probably come on to that down the line as well.
Yeah.
On that note, I think we'll end the show at that. We've done selection. We've touched on if statements. We're going to be doing if statements a lot more next week. And finally, we'll be getting loopy. I was so excited for the getting loopy episode, but I think we ended up going into a little bit more detail on this than we planned. But hopefully, everyone found that really useful. So we now have, with our really basic eggs program, we now have the basis of a really simple piece of software. And if that's all you're doing, if all you're doing is doing some checks and adding numbers, actually you can write fairly complex software without ever going beyond that. Just using the if statements, just using the inputs and operators, you can actually create something that is relatively complex. But loops open up a whole new world. I just want to start singing an ad in there. A whole new world.
Yeah.
Fantastic operations. No, I'm not going to start. Not live on YouTube. Well, thank you for tuning in. Hopefully you've all found this really useful. Let's say next week we will definitely be getting onto loops. I'm gonna have to rename this in the YouTube titling. But yeah, thank you for tuning in, and we'll see you next week.
Bye, guys.